next we are going to see about BMS IC selection. So first of all, how you select your battery management system IC? What are the parameters you should keep in mind while selecting your BMS IC? So first we need to know that what is battery cell chemistry. So before that, in this topic we will cover some how to select an IC that is appropriate for the battery management system that you want to implement. So there are many ICs available on the market that aid the functioning of the battery management system. There are variety of factors that need to be considered before choosing which IC is the most beneficial for your particular battery management system. So some factors include things such as the battery chemistry, cell chemistry, number of cells in series, protection needed, and whether a balancing is needed, monitoring including voltage, current, temperature, SOC estimation, technique, FET controller, fault detection, the necessary interfacing protocol, whether a microcontroller is needed for your system or not. So I can explain these factors more in depth below. So first one is the battery cell chemistry. So one important factor is the type of the battery that your battery management system uses. So this can be lithium ion cells or lithium iron phosphate cells also. This is the most important because the different types of cells have a different nominal voltage levels. Lithium iron phosphate cells have a nominal voltage about 3.2 voltage. On the other hand, lithium ion cells have a nominal voltage of 3.6 to 3.7 volt. So it is important to know which cell you are using for the nominal voltage level of the cell. So this is an important parameter before we need to selecting our IC. Next one is the number of cells in series. Another important factor when choosing an IC is the number of cells there are in a series in the system. Varying ICs can deal with varying number of cells in series. So that is important to work with an IC that can accommodate the total number of cells in the system. So next one is a protection. So one of the most important thing that a battery management system needs to offer is a protection. So a battery system needs a protection from things such as the over voltage condition, under voltage condition, over current condition, and as the short circuit, open circuit, and over temperature and also under temperature conditions. So several of these factors are shown above can serious safety concerns and also the possibility of fire. So therefore, it is important to get an IC that has a necessary protection for your battery management system. So over voltage condition can destroy the battery's life. That means the state of health of the battery. In some events can cause a fire if a high enough. Under voltage conditions lead to an inefficient system where charging may not be adequate and also the system may not output sufficient power. Next one, open wire conditions. So these conditions, they are disconnected or poorly connected wires which can cause error with the BMS. So this identification of a fault wiring can prevent issues of safety and performance of the system. Next one, overcurrent or short circuit conditions can cause over temperature conditions can lead to fire. Over temperature conditions can signal a catastrophic event in the system and the BMS needs to take some appropriate actions to implement cooling or shut down the battery. So all these conditions can be addressed by selecting an appropriate IC that can offer a high protection against these happen. So next one is a cell balance. Another very important consideration is whether your system requires cell balancing or not. If you need a cell balancing, then you need to know whether you require passive cell balancing or an active cell balancing. So pretty much all BMS ICs provide a passive cell balancing capabilities. Only few ICs provide active cell balance. So these require a more specialized search. So next one is a monitoring. So another thing you need to consider is a monitoring. You need in your BMS. So this includes the voltage monitoring, temperature monitoring, and also the current monitoring. Many of the IC, the voltage monitoring and temperature monitoring are built into the IC. So current monitoring would be more difficult to find in IC. In the case the BMS chip does not have the monitoring for record. So would need some external circuitry to provide the monitor. Next one is the SOC estimation technique. So another most important thing must be considered is what type of SOC estimation technique you are looking for. So this serves as a fuel gauge of the for the battery to determine its charge. Some BMS IC provide this directly so that the state of charge can be measured. So if the BMS IC lack this capability, so you will need to catch this externally. We have to connect it. So next one is the drive control. So another consideration is a means of control of the battery from either the load or the charger. This can be done mechanically through a contactor and external to the IC, or it can be done internally in the IC through a field effect transistor, that means the FET, such as a MOSFET transistor. So next one is the fault detection. So another important consideration is a fault detection. So if it recovers a fault in the system, do you want to simply an alert that a fault has occurred, or do you recover more advanced functionalities detecting the fault and then implementing system changes such as an automatic shutdown? So some BMS ICs simply detect faults, while others can detect a fault and implementation system responses to reaction to the fault. Next one is the interface protocol. So if you are using an external IC for some of the capability, you will need to connect it to the BMS IC and use some communication protocol so that the two ICs can communicate with each other. Therefore, your BMS IC must have an interfacing protocol, whether it be UART, I2C, next one is ISPA, etc., to be able to communicate with the external IC. So if you are just using the BMS IC stand alone, then you won't have to worry about an interfacing protocol, as you don't recover external communication with another IC. Next one is the automotive grade or industrial grade IC. There are two major types of grades of BMS IC. First one is the automotive grade or industrial grade IC. Automotive grade are recovered and used in the automotive industry, and they are a higher quality than the industrial grade. Thus, they tend to more expensive. If you are using your application for a non-automotive, then the industrial grade may be suitable and it is more economical also. So these are criteria needed to help you select the necessary BMS IC for your application. Next, we are going to learn about a microcontroller for a BMS. So, what type of microcontroller you can use? Then what features you need to keep inside your microcontroller for your battery management system application? So, mainly, microcontroller is purely based on the complexity of the system, and low voltage application does not recover microcontroller. Mid voltage with simpler features, low cost generic microcontroller. Automotive high voltage application with the complex functionalities that also can recover high end automotive grade EMS microcontroller or FPG. So what are the selection techniques? In this topic, we are going to learn about the selection techniques of a MCU for a BMS. So now we will be focusing more towards the features of the microcontroller which are recovered for a BMC. So first thing, we need to check how your BMS chip is communicating with your microcontroller. Next, second thing, how many number of ADC channel are recovered for your application also. Third thing, so which all communication protocols are recovered. So, if for example, you might be recovering a CAN communication for interfacing between the components of the electric vehicle. Then you might be recovering I2C communication for communicating with the EW or RTC, some other sensor. So you might also recover for SPA for interfacing with LCD light like that. So you need UART communication for debugging purpose or GSM Bluetooth purposes. Digital control pins also needs to be considered. And the last thing that you recover are two grades. So that means auto grade and industrial grade microcontroller based on your application. So these are the few parameters you need to consider before designing the BMS. So next we are going to talk about an overview of the microcontroller in battery management system. So mainly this functional blocks of the battery management system comprises a control block which is the microcontroller and also the sensing block which is the analog front end. So let's get into deeper into the microcontroller of a BMS. This is a microcontroller unit. So what is a microcontroller unit? So this is a brain inside the BMS. And MCU captures all the data from the sensors through its peripherals and the processes the data based on the configuration file of the battery pack to make an appropriate decisions. So mainly this MCU has the following functions. So first one is the monitor the battery and protect the battery, and also the estimate the battery state and maximize the battery's performance and data logging, and it will send a report to users or some external devices through communication. For a cell safety, the MCU has the following functionality also. So prevent any cell from going into an overvoltage situation inside the battery pack. This is achieved by giving a turn off signal to the contact. So next one, prevent the temperature of any cell exceeding the upper threshold limit by reducing or stopping the current or activating the cooling system in the battery. So this protects the battery from thermal runaway, which is a safety issue. Next one is to prevent any cell from going into an undervoltage situation also by limiting or stopping the discharge current. So protect the battery pack from a short circuit and overload situations by opening the contactor also. So next we are going to see about some essential functional blocks of the BMS that can be connected to the microcontroller. So this MCU is connected to multiple functional blocks. Now, what is the functional blocks? So let's see one by one. So these are all the functional blocks. The first one is a Hall effect sensor and power supply and contactors. And next one is IST cord. And next is RT. So that means a real-time clock and also a calendar. So next one is a GPIO connector, CAN connector, Bluetooth, high voltage interlock loop. Also, so IMD means installation monitoring a device. So next one is the voltage measurement port. So next one is the communication channel port. So that means the ISO SPA channel. So let's see one by one. So first, a Hall effect sensor. So what is a Hall effect sensor? What is the principle behind the Hall effect sensor? So we all know Hall effect sensor is placed inside the magnetic field produced by a cable that carries back current. It produces a voltage proportional to the current. That voltage can be measured directly as shown in the figure. So mainly Hall effect sensors are characterized by the following. The current reported by a Hall effect sensor remains accurate over time and temperature. So next one is a Hall effect sensor are isolated from the pack current. That means a battery pack current. Therefore, no isolation is needed. Also, Hall effect sensors suffer from offset at a zero current, which changes with the temperature. So even if they are zeroed at a room temperature, they will report a small current when there is not at one as they get hot or cold. Frequent calibration is required in applications that have periods of zero current, such as a HEV. So, Hall effect sensors are models that include their own amplifier, so their output is at a high level, unlike the signal of current shuts. So, yeah, supply of a 5-volt bidirectional can power them, can see both charging and discharging current. The output of a bidirectional sensor is a bipolar. It will be swing above and below the 2.5 volt. The voltage output generated by the current sensor will send it back to the battery management system. So that battery management system will estimate the actual current based on the sensitivity of the current sensor. So based on that, their output can be referenced to 2 ampere to 2.5. So next one is the power supply. So for the functionality of the MCU, it requires some power input, which is given by auxiliary power supply or from the battery pack itself through a DC to DC converter. Next one is the contact. So what is the contactor? The contactor is a functional block that connects and isolates a battery pack between the load and the charger. So generally, the battery pack system has a 3 different contactors. So first one is a charge, a discharge, and also the pre-charge. There will be only one contactor for a charge and discharge in some applications, like energy storage system. The BMS controls the switching of the contactor through a driver circuit also. So the BMS will give energizing signals to the driver circuit, which energizes the contactor for the operation. The contactor selection is mainly based on the charge and discharge current. We can go for a MOSFET based solution for a low current and low voltage application instead of the contactor. Next one is the SD card. So it can store the information file of the BMS and send the data which is generated by the battery. So BMS can store the battery data for 15 years. So this allows the user to understand the battery's pack behavior and safeguard the battery from potential damage. So next one is the real-time clock and calendar. So what is the RTC? So here you can see the RTC page. So mainly this is used for giving a timestamp for the data stored in the SD card. This helps the user to conduct a root cause analysis if any potential damage happened to the battery pack at any point in time. So next one is the GPIO connectors. So mainly these connectors give the provision of connecting extra functions to the BMS like a cooling system, heating system, emissions, sensors, etc. Enabling this functionality done by making changes in the configuration. So next one is the CAN connector. What is the CAN connector? We all know about a CAN connector. So CAN connector is peripherally connected to the microcontroller, which is made for internal and external communication. Internal communication is required if there are a multiple BMS connected in a system. External communication is generally meant for exchanging messages like voltage, current, temperature, errors, etc. External communication is generally used in a CAN charger and CAN display and also the CAN data log. So next one is the Bluetooth. So mainly this Bluetooth enables a wireless mode of a communication with the BMS. And also this is a Android application used to interface remotely with the energy BMS via Bluetooth. So next one is the high voltage interlock loop. So this interlock pulse width modulation loop mechanism used to detect a tampering or opening of the high voltage equipment or a service disconnect switch. So a high voltage interlock loop determines if a high voltage system such as a power source, that means example we have to take as a vehicle battery, a load. So it will take as a vehicle motor and conductors there between. So having correctly connected, if not means the battery contactor is not allowed to be closed or if already closed. So it will give a command to open it. So next is the IMD. So what is this IMD? So insulation monitoring devices. So IMD stands for insulation monitoring devices. So mainly this IMD generally comes in electric vehicles and also the ESS applications. So it will ensure electrical safety and reliability in electric vehicles equipped with a high voltage battery pack. So mainly this IMD continuously monitors the insulation resistance in the system between the phase conductor under the ground during a charging or a discharge. So next one is the voltage measurement board. The terminals are connected across the contactors are primarily used for check the battery total voltage measurement and voltage based pre-charge. So for high voltage and high current applications, there is a chance that the contactor may get welded. So in this scenario, The contactor is not allowed to be open if the BMS gives an opening signal. So the BMS identifies that the welding has occurred in the contactor and sends an alert message over CAN to external devices for taking the emergency action. So next one is the ISO SPA channel. So this is these also comes from the communication protocol. So ISO SPA channel is meant for internal communication master and slave. That means the master means control circuit and slave means sensor circuit. So these are all the functional blocks in a microcontroller or for a battery management system. So these parameters we should keep in mind before we have to select the type of IC and also the microcontroller. So thank you all.